Hi, my name's Jono, asphalt foreman here at Fulton Hogan. Today I'm introducing you to a video on ride quality. It's a 360-degree video, so you can have a look around and check it out. Go on, have a look. Over here we've got a shuttle buggy parked up. Great looking bit of gear. And some asphalt trucks lined up behind it as well. Alright, look back over here, Sticky Beaks. Go on, back over here. You'll see behind me you've got an asphalt paver setting up, so I better get back to it. Enjoy the video.
What is ride quality? Ride quality, also known as the bump count, is an indicator of how smooth the road is. The unit of measure is IRI, International Roughness Indicator, and is measured by how many bumps there are over a 1 kilometre distance. So, why is ride quality important? There are three main reasons why so much value is placed on ride quality. Firstly, it has a considerable impact on vehicle maintenance and operating costs. Take a look at these facts. Studies have shown that driving on smooth surfaces can reduce fuel consumption by up to 5% compared to driving on rough surfaces. Driving on poor road surfaces is estimated to cost the motorist approximately $400 per year in additional tyre wear and general maintenance. The second reason we value ride quality is so that our roads last longer. Too many bumps and the road wears out sooner from dynamic loads, particularly at speeds in excess of 80 kilometers an hour. An increase in pavement smoothness by 25% is estimated to increase the life of the pavement by around 10%. And the third reason is the impact that it has on road user comfort. Smooth roads means less noise and less bouncing, and that's better for everyone. So, what are the factors that influence ride quality? Firstly, we have the design of the pavement and the environmental factors. These include things like the quality of the subgrade, the selection of the pavement type, the materials, the thickness, and so on. In addition, vegetation, such as trees on the side of the road, can impact. For example, parts of a road that are in constant shade are exposed to different temperatures over time. Secondly, it's the routine maintenance activities such as the methods used for patching and pothole repairs and how well the drainage systems are maintained. Thirdly, it's the construction of the asphalt pavement. This is where we come in. With regards to the role we play in the ultimate ride quality of the road, there are a number of important factors to consider. These factors include job planning, paver setup and level control, uniform spreading, joints, and rolling techniques. Now let's explore each of these in more detail and how they help us deliver a quality job. Just pitching up on the day is not good enough, and there are a number of factors that we need to consider in our planning if our objective is to produce a road with good ride quality. On new pavements, thick layers are good for achieving density and increasing productivity. However, they tend to move more under rolling and make it more difficult to achieve shape. The key in planning is to achieve the optimum balance between these conflicting demands. Asphalt placed over an irregular surface will reflect some of the existing shape, and a regulation or corrector layer will do much to improve the outcome. Alternatively, by profiling out the highs, you are also able to improve the outcome. Plan the location of the joints to keep them to a minimum and out of the wheel paths. Plan asphalt delivery rates to maintain steady, continuous paving without the mix standing for too long prior to laying. Lay outwards from fixed levels. Ensure that the correct gear is selected. Firstly, the selection of the paver should suit the mix being laid and the width of the lanes. You don't want a paver that's too big or too small. Secondly, ensure that the number and the size of the rollers will cope with the speed of the paver. Most importantly, when working to fixed reference points such as taking off from an existing pavement or bridge deck, string lining on approach and departure is a good method to ensure a smooth transition. This process includes the following. From the fixed reference point, take a string line at least 10 metres out ahead along the line of the paving width. Position the string line on the surface of the fixed reference point and a block or jack set at the correct paving thickness. Along this line, take measurements from the string line down to the road surface. Add the normal approximate 25% of depth for compaction and spray paint this depth onto the surface. As the paving progresses, the level hand is able to make the necessary adjustments according to the recorded measurements and checks this through dipping. This ensures the final transition between the existing and the new surface is as smooth as possible. Another factor to be considered is how pits are handled. This is regardless of whether they be small pits in the middle of the road or graded pits on the side of the road in the running lanes. There are a number of points to consider in this regard. The common practice of going around pits that are just within the paving run by bringing in the screed extensions has an impact on ride quality and should be avoided. This practice of bringing in the screed extension can result in a bump as you squeeze the material back against itself, which increases the head of the material. We need to treat pits as fixed points and utilise the stringing approach as we just covered. Importantly, if this approach is taken, we need to ensure that graded pits are covered so that asphalt doesn't enter the openings. However, this does depend on whether the pits have been set at the correct height prior to commencing paving. If this approach is followed on pits set at the incorrect height, it can have a significant impact on the final ride quality. In this case, it is advisable to consult with the client on the possible alternatives, including repositioning of the pits. Where it is unavoidable and the extensions have to be brought in on the approach to a pit, care must be taken on approach to manage the feed to the extension carefully with gradual adjustments being made. This helps ensure that the head of material remains as constant as possible as the extension is brought in. Sequencing of paving runs can have a significant impact on the ride quality achieved, and this needs to be taken into account at the planning stage. For example, as the ride quality is normally more critical along the length of the through runs, these through runs should be paved first, with tapers and turning lanes done afterwards. In this way, the through run provides the fixed reference point from which the tapers and turning lanes can be taken from, instead of trying to match in the through run levels with the different tapers and turning lanes along the way. Paver setup and level control. Proper paver setup is as important for ensuring a good ride quality as it is for achieving uniform compaction. Firstly, a constant head of material is required, and this is achieved by ensuring a constant flow of material from paver hopper to screed by adjusting the conveyor speed to that of the auger speed, adjusting the hopper flow gates to ensure an even flow of material to the screed, always utilising auger and tunnel extensions when paving wide runs. Always ensure that the auger height and the speed is adjusted for different depths of pavement. Secondly, side plates must always be down close to the ground, as this will help to compact the edge of the mat and keep a constant head of material. Thirdly, when using extensions, ensure that the angle of attack of the screed extension is the same as the main screed. Finally, always ensure that the paver is correctly set up at the start of each run. 1. Set the paver down on slats, shims, that are the height of the asphalt roll down. They should be long enough to make contact with the main screed and extenders to eliminate a false null and to carry the screed until it's suspended by the asphalt. 2. Null out the screed on the shims. 3. Ensure both sides of the screed are set the same, the toe arm line of pull and a similar angle of attack. This must be done at the same time. 4. Induce a slight angle of attack into the screed to prevent it from diving. There are a number of other aspects regarding the paver to be aware of if we are to ensure the best possible ride quality, and these include the following. 1. An improperly cleaned and therefore not free-floating end gate can cause problems in the function of the grade and slope controls, affecting ride quality. 2. Emptying the paver hopper can cause segregation and different temperatures in the mix. Lift the hopper wings when the hopper is relatively full. 3. The paver is designed to provide a smooth surface behind the screed with the least amount of interference. Constantly adjusting the screed height, such as chasing levels, can cause roughness in the finished surface. 4. Making smooth progressive adjustments without the need for overcorrection are key skills in achieving a smooth surface. However, it can be quite challenging to achieve a good ride quality through manual adjustment, as these adjustments need to be fed in gradually, several meters ahead of where the altered thickness is required. For this reason, the use of automatic controls is recommended. 5. The condition of the paver can also have a large impact on the ride quality, and the important aspects to be aware of when selecting a suitable paver for the job include: overinflated tyres can cause the wheels to slip. Loose drive chains or an engine out of tune can cause an uneven surging motion. Worn augers will affect material flow. Loose pivot points and worn crank screws can cause difficulty in controlling the angle of attack. Worn or buckled screed plates. There are a number of automatic controls commonly used, including 1. Leveling beam. The leveling beam assists in improving ride quality by averaging out surface variations over the distance of the beam. There are a number of different types of leveling beams available, and personnel need to be trained in the use of each specific type of beam. Although manual overriding of level controls should be kept at a minimum, close observation should be maintained rather than initially setting the levels of the beam and then ignoring them. 2. Joint matcher. Where there is a suitable fixed reference point, like a previous run or curbing, the joint matcher is a simple but effective tool to match in with the existing surface. These joint matchers normally come either in the form of a mechanical shoe riding on the surface or sonic level sensors. 3. Computerized electronic control. Where ride quality is of critical importance, such as major freeways or airport runways, the use of computerized electronic controls is recommended. However, in order to gain full benefit from this more costly method, the paver needs to be in good condition, with the control systems responding accurately to the input data. For this reason, the newest paver in the arsenal is normally used for this type of work. Accurate levels are taken over the length of the run, and this data is entered into the computerized level controller. As the paver progresses along the run, adjustments are automatically made to the levels based on the data previously entered. Pause to discuss. Why should we move the paver off the mat and square off when there is a lengthy delay? Why is the following important? Good communication between plant and paving crew, running out the remaining mix, lifting the screed and moving out of the way. Placing boards at right angles to the direction of travel. Cutting the edge back and utilizing downtime. Five, uniform spreading. 1. The golden rule for uniform spreading is continuous constant speed paving. The paver speed should be matched to roller capacity, plant production, and material delivery capacity. The message here is simple. Keep the paver moving consistently and not stop-start. If the paver is stationary for any length of time, the asphalt in front of the screed can cool down, resulting in compaction and ride problems once paving recommences. In order to avoid this occurring, the following needs to be undertaken.
Good communication needs to be maintained between plant and paving crew to ensure that delays are effectively managed.
The paver needs to run out the remaining mix, lift its screed and move out of the way.
Boards, the thickness of the final mat, should be placed at right angles to the direction of travel, allowing the rollers to effectively compact the mat without damaging the edge.
The edge needs to be cut back using a straight edge to ensure a neat joint. The paver is then moved back into position and asphalting recommences.
During the period of the delay, if the rollers are not required for compaction, boards need to be placed at longitudinal or lateral open edges and the rollers exit the new mat. This is a good time for the rollers to refuel or stock up with water.
2. It is therefore essential that a sufficient number of truckloads of asphalt are on site before paving is commenced to avoid stop-start problems, but not so many that the mix can go cold before being used. 3. Delivery trucks must not be allowed to bump the paver by directly reversing into it. Instead, the truck should stop short of the paver, in neutral, with just enough brake pressure necessary to prevent the truck rolling downhill, and allow the paver to engage the truck and propel it forward while asphalt is tipped slowly into the paver hopper. The use of material transfer vehicles, or shuttle buggies as they are more commonly referred to, can play a significant role in ensuring that an excellent ride quality is achieved. The three main factors which lead to improved ride quality are: remixing the mix ensures a homogeneous mix with constant temperatures throughout, ensures that delivery trucks are kept away from the paver with no danger of bumping into them as previously mentioned, provides an additional surge capacity in its hopper to smooth out supply between truck deliveries and ensure that the paver does not run out of mix. Joints. 1. The impact of longitudinal joints can largely be eliminated by ensuring that these joints do not fall into the vehicle wheel paths. However, transverse joints can have a major impact on ride quality and need to be managed effectively. 2. The first prize is to reduce the number of transverse joints by making the paving runs as long as possible. 3. Transverse joints are commonly a result of paving being interrupted by either construction requirements or simply work being halted at the end of a shift.
At the end of the day's run, the asphalt is also often ramped down to allow for traffic, and this ramp is required to be removed before the start of the next day's production.
4. Before paving can continue, any asphalt ramp must be profiled back to a point where the layer is full depth, compacted and even. This is best achieved by using a straight edge along the line of the run, ensuring that the material is cut back far enough to reach full depth.
5.
Transverse joints are generally done approximately at right angles to the direction of paving. However, constructing joints diagonally across the line of road will provide a better ride with vehicle tyres hitting the joint at different times.
6.
Wherever possible, the transverse joint should be rolled along the line of the joint, cross-rolled, with a steel wheel roller, initially overlapping about 150mm onto the fresh mix. This should continue for several passes, projecting about 200mm further onto the mat each pass before commencing normal longitudinal rolling.
7. The joint should be checked with a 3-metre straight edge immediately following rolling of each lane to help correct any deviations. 8. Unacceptable joints are also caused by using the entire head of the material at the end of the day's paving. This is poor economy, as depleting the head of material causes the screed to drop and results in a long gradual reduction in mat thickness. When paving resumes, with the screed nulled on this tapered mat, a dip will occur. To avoid this issue, the head of material should be held until the works are completed. This ensures there is sufficient material in front of the screed to maintain the required paving depth. 9. After constructing either a transverse or a longitudinal joint, all additional segregated aggregate from hand placement must be removed and not broadcast over the mat. Similarly, it is poor practice to finish machine spreading some way from the end of the run, lifting the screed, dumping asphalt from the paver, and then hand spreading the remaining material to finish the run. The hand spread material rarely matches the surface finish and uniformity of the machine placed material. Rolling technique. 1. Rollers that are operating at slightly faster than walking pace will achieve the best results. 2. Increasing the speed of the rollers is likely to poorly influence both the final riding surface and the mat compaction. 3. If the mix is being adversely affected by rolling, the speeds should be reduced to prevent excessive displacement. 4. If the speed is too high, surface disruptions such as ripples or washboard marks and ridges will occur from overrun bow waves. If transverse cracks appear in the surface, the roller should be removed until the mix is sufficiently stable to support the roller. 5. Newly placed asphalt has a tendency to want to displace laterally when vertical pressure is added to the surface. For the best ride quality, the mat must be constrained. That is to say that the mat should, as near as practicable, be fixed at either side by either a roller pass or a fixed object such as curbing. 6. Secondary or intermediate rolling is generally accomplished with a multi-tired roller. 7. If the vibrating pneumatic tired units are properly maintained and operating on the newly laid mat early, then considerable improvement can be seen in both mat compaction and surface texture, especially in the case of harsh or tender mixes. 8. Pneumatic tired rollers are not efficient unless operating at the manufacturer's recommended tire pressure. 9. Rolling should continue until the roller pattern is complete. Typically, the rolling pattern for a multi-tired roller is moving one wheel at a time across the entire mat, beginning from the lower side and working up towards the higher side. 10. Treat transverse joints as a continuation in the mat after they have been rolled by a steel roller, and do not stop on a transverse joint. 11. Final or finish rolling is the final step in improving surface smoothness, generally achieved with a static steel wheel roller. Final rolling is carried out to produce a uniform finish free of roller marks. The process is normally carried out by steel rollers in the non-vibratory mode. The rolling should be completed as soon as practicable whilst the surface is still warm. Here's a few extra tips on achieving a smooth surface. Rolling should not commence until any deficiencies in the newly placed material are corrected. Rollers should not be allowed to stand on the recently compacted asphalt until the layer is sufficiently cool. This prevents the mat deforming under the static load. Where possible, remove the other rollers from the fresh mat by the use of boards. Once the mix is cooled, it is difficult to remove any roller marks. Vibrators need to be turned off before the end of a pass, with sufficient time for the vibrators to be in a static state before the roller has come to a stopped position and a change in direction is made. 5. Lateral changes in direction of rolling are best undertaken on previously compacted asphalt. Sharp turning should be avoided, and changes from forward to reverse should be made smoothly.
All of the points covered in this video are important. However, there are a few that are critical in ensuring the best ride quality, and they are: A. Plan the job so that you can ensure continuous constant speed paving by taking plant supply capacity, turnaround time of the delivery trucks, the gear on site, and the job itself into account. B. If taking off from fixed reference points, use a string line at approach and departure to ensure a smooth transition. C. Ensure that the head of the material is kept constant. D. Do not let the delivery truck bump into the pavers. E. Ensure that the paver is set up correctly at the start of each run. F. Ensure that the material delivered to the paver is uniform. And finally, minimize the number of transverse joints, and those that you have to have, do them properly.
Well guys, hope you enjoyed the video and picked up a few pointers on ride quality. We all take pride in our work, so keep it real and stay safe. I'll see you out in the job.